Alright, so Unit 3 was exponents and logs. Part of this unit we had to figure out how to go from exponential form to logarithmic form. And basically the reason why we would go from form to form is to solve equations, to figure out what is the value of the variable that's unknown. Some of the questions we looked at was solving an exponential equation whose powers can be written in the same base. So looking here, can 9, 27, and 3 be written in the same base? Absolutely. 9 can be written as 3 squared, and then it will be to the power of x. (27) can be written as 3 cubed. And this fourth root of 3 can be written as 3 to the power of 1/4. So just cleaning things up a bit, I have 3 to the power of 2x equals, same base, which means you can add the exponents here. So I'll just do that up top. 3 plus 1/4, I need to have a common denominator of 4, so I'd multiply by 4. 12 plus 1 is 13 over 4. So 3 to the power of 13 over 4. Okay, so we have 3 to the power of 2x equals 3 to the power of 13 over 4. Once these bases are the same, what can I do with those equations, or the exponents? Set them equal. Okay, so now I have 2x equals 13 over 4. To get x by itself, I just need to divide by 2. So x equals 13 over 8. Voila. Okay, now if adding fractions and whole numbers isn't your strong suit, just put it in your calculator, math frac. Okay? So next type of question you might see would be when you can't find a common base. One method to solving this would be to put it in your calculator. Okay, and that's in the how-to here. We have y1 equals to the left side of the equation, y2 would be the right-hand side, and we're trying to find the intersection point for those two graphs. So if you're asked to solve an equation like this, quick way, put it in your calculator. Okay, another way, which we're not going to use in this question here to solve, is to apply a log on both sides. Okay, but we don't need to do that in this case. What we can do though is convert this to log form. Okay, so I'm going to go 1.04 to the power of 2x equals 2. Into log form will be log, what's your base? 1.04. Okay, my argument will be 2, and that will be equal to the exponent, 2x. That's the whole point of changing forms, so that I get my answer out of the mess, out of the exponent, and it's equal to it. Okay, change of base, log 2 over log 1.04. If your calculator can't calculate this right away, you have to do change of base and calculate it log 2 divided by log 1.04. That still equals 2x. Okay, to get x by itself, I'm going to have to divide by 2 on both sides, and you'll get log 2 divided by 2 times log 1.04. Okay, so when you guys calculate that, just confirm what you get. I'll confirm it back. I got, yeah, 8.8, perfect. Okay, does anyone need a hand calculating that? Yeah.
2 divided by 2.
Yeah. So I'll go back a step for you. Okay, I want you to evaluate what is log 2 divided by log 1.04 first.
Calculate that first.
Yep. 17 point something.
6, 7.
Okay. Now if I want to solve for x, then I can divide by 2. If we're rounding to the nearest tenth, 8.8, yeah. Of course, you have to be careful on your, if this was a numerical response question, make sure you're rounding accurately to what they want. If these are your boxes, you always fill it in left to right. So I would go 8, the decimal gets its very own box, and then 8. That's if they say round to the nearest tenth. What if they said round to the nearest whole number? 9. Don't make a silly mistake and lose a mark because you didn't put it in the right box. Okay? And then also make sure you fill in the bubbles that go with it. Alright, a little bit of practice of changing from exponential form to log form and log exponential form. Alright, what's our base from log 381 equals 4? Well, that's 3. And if we're going to exponential form, it'd be 3 to the power of 4 equals 81. You'll know you did it right because this will work out. When you calculate 3 to the power of 4, does it equal 81? Yes. Okay, now if you put 4 to the power of 3, you're not going to get the same thing. So please make sure whatever the base is of the log, it's the base of the exponent. Okay, now we're going to put 6 squared equals 36 into logarithmic form. So again, the base of the exponent will be the base of the log, base 6. Argument 36 should equal 2. And if you calculate that, log 36 over log 6, you should get 2. Otherwise, you put it into the wrong form. So if you were to calculate log 36 divided by log 6, that's what this means, it should equal 2. And if it doesn't, then you probably did the wrong form. Okay. Now what seemed difficult before, hopefully is easy now. We learned about some laws of logs. Just to review, this one is called the product law. Okay, we have log x plus log y equals log x times y. You can only apply the product, the quotient, and the power law when, what about the bases? The bases have to be the same. So I'm just going to put a big note here. Bases must be the same. Okay, with the product law, oh sorry.
All of that's a product law?
No, just this top one is the product law. We're going to go through the other ones next. So if you're adding logs with the same base, you take the arguments x, y, and you can multiply them x times y. Okay, the next one is called the quotient law. If you have logs with the same base, but rather than adding, we're subtracting, then you can divide the arguments. X, y becomes x divided by y. Please make sure you guys are careful with this. It's one logarithm on the right-hand side. I've seen many times people write out log x minus log y as this, log x divided by log y. That is so wrong. Okay? So please make sure you're careful. It's one logarithm. The arguments go into one set of brackets. Okay? And the last one, we call it the power law. We have log x to the power of m. What happens to that exponent m? Well, it can be brought in front. So the probably have time for one more question.
So
Yeah.
you're saying like bases must be the same for like all of them, or
Yeah.
just the product?
So do you see how this was base 10, base 10?
So all
If these bases are the same, then you can apply the quotient law.
so like in
If
order
they're a
to
6 and a 6, then this would be,
so like in order to do any of those laws, we just have to do the same.
yeah. Now for this one, not necessarily, because you can just, it actually doesn't matter for the last one. If that's, because there's only one term, right? So it doesn't matter. So sorry, technically just for product and quotient law, bases must be the same. Any other questions?
Wait. So just for how product and
Yeah, and hopefully that's pretty obvious because you only have one term for this, right?
yeah.
So all you're doing is moving that exponent. Okay, a very common question, you probably will see something like this, but maybe more complex on your diploma. You have to write a chain of logarithms as a single log. So to do that, automatically think product, quotient, and power law. Okay, you want to use your laws of logs. So when you see a coefficient out front, what law should I use? Power law. So 2 log x becomes log x squared. And maybe on the side, I'll just write power law to start. That's what we're going to do first. Okay, log x squared. Can't do anything with the middle term quite yet, so I'm just going to leave that as is. Log y. Okay, and here I have a negative 3 log z. I have a coefficient out front. Power law. So I'm going to leave the negative there, but I'm going to move that 3 as an exponent on the z. Alright, done with the power law. Do all these logarithms, each term, do they have the same basis?
Yes.
So I can apply now the product law and the quotient law. And I know it's going to be both because I have an addition and a subtraction. So if you want, you can do it all in one step, or you can break it down slower. I'm going to do it in one step. Product and quotient law. Okay, I know that I will have one logarithm. If I'm adding logarithms with the same base, what do I do with the arguments? Multiply. So I have x squared times y. Now the last term, I'm subtracting log z cubed. So whenever we subtract, what happens? It goes in the denominator. Here, log y was being subtracted, y is in the denominator. Here we're subtracting z cubed, so z cubed is in the denominator. And we're done. That's a single log. Not so bad, hey? We're going to freeze there today, pick it up tomorrow.